Example 7. We're going to start by finding our asymptotes. My vertical asymptotes, I'm setting my denominator equal to 0. I'm going to have to factor, since it's a quadratic, the two numbers that multiply to 16 and add to 8 are 4 and 4. We get a vertical asymptote of x equals negative 4. For my horizontal asymptotes, I notice that my degrees are equal. So we're going to do leading coefficient divided by leading coefficient. 3 divided by 1 is just 3. I don't have a slant asymptote because my degrees are equal. To find my y-intercept, I'm plugging 0 in for x. Hopefully by now you know the trick and you can just tell me what the y-intercept is. But if you need to, you can actually plug it into the equation. We get negative 6 over 16, which we simplify to the point 0, comma, negative 3/8. Step 4, we get our x-intercepts by setting our function equal to 0, which essentially is the same thing as setting my numerator equal to 0. I have a quadratic here with a greater than 1. I have a equals 3. So luckily I can just divide a factor of 3 out of everything and I don't have to factor by grouping. Two numbers that multiply to negative 2 and add to negative 1 are negative 2 and 1. So I get two intercepts this time, the point 2, comma 0 and the point negative 1, comma 0. Step 5, we need to figure out if our graph intersects the horizontal asymptote. Remember, our horizontal asymptote is at y equals 3. So we're going to take our equation and set it equal to 3. So the way that we're going to solve this is we need to get rid of the fraction. So we're just going to take our denominator and multiply it on both sides. On the left side, the denominator cancels out, and I'm left with just the numerator. On the right side, I'm going to distribute that 3. Okay, so now solving this, I'm going to start with my x squareds. I notice that I have 3x squared on both sides. If I subtract it over, those are just going to cancel out. So now I'm going to move my negative 3x over by adding it. And then subtract over my 48. In the end, we get x equals negative 2. So my answer is yes, we cross the horizontal asymptote at the point negative 2, comma 3. X was negative 2, and y was the 3. That's what we set our function equal to. Okay, I've gone ahead and graphed what we know. I have both of my asymptotes on here, as well as my 2 x-intercepts, my 1 y-intercept, and the point negative 2, 3, where we cross our horizontal asymptote. Let's start with the left side of x equals negative 4. We need to test a number over here to see what our graph is doing, whether it's below the horizontal asymptote or above it. Let's test 5. Okay, so whenever we test negative 5, I think I may have said positive 5 a minute ago, but I meant negative 5. We get out 84, which is a positive number, and it's bigger than 3. So we know we're going to be above the y equals 3 line. So my graph is going to look like this. If I had gotten out a number that was lower than 3, then I would have been below my horizontal asymptote. Now let's look at the right side of x equals negative 4 and try to connect the dots that we have going on here. First of all, I know that I can connect these, and I don't have any other x or y intercepts, so I know that my graph is definitely not going to be going back down. I know that I only cross my horizontal asymptote right here, so I can finish my graph off with a volcano here at the top and flattening out right here towards my horizontal asymptote. And here's what our graph should look like. So this was the first example where we crossed an asymptote. Again, that can happen when your graph is anywhere that your graph is not heading off towards infinity or a certain number. So anytime we've got the edges of our graph, so where we have the arrows, those are going to get close and closer and closer to the asymptotes, but never cross them. Let's look at the behaviors of our graph at different vertical asymptote situations. So if I have a vertical asymptote and it has a degree on it, so an in value that's even, I'm going to have a volcano happening. It's either going to volcano up or it's going to volcano down. If I have an asymptote that has a degree or a multiplicity of an odd number, I'm going to have something like we have on the right here, where one side goes up to positive infinity and one side goes down to negative infinity. Looking back at this example that we just did, we could have known early on that my graph was going to volcano like this, because whenever we found our vertical asymptote, we factored the denominator to be x plus 4 times x plus 4. So right there we had x plus 4 squared. This is a quick reminder of behaviors at graphs at intercepts. So if we have an intercept with multiplicity of 1, our graph is just going to go through, like we have in this example. If our intercept has a multiplicity that's even, then we're going to bounce off of our x-axis and go back the way we came, or turn around. If the multiplicity of our intercept is odd, but bigger than 1, we're going to do what's called wiggle at that intercept. Example 8, we're going to graph this function. First of all, we're going to start off with asymptotes, which we actually found way back in example 4. So we have a vertical asymptote at x equals 2. We also have an oblique asymptote at y equals x plus 2. Remember, we found that by doing synthetic division. Our y-intercept, if you plug 0 in for all of our x's, you're going to get out negative 1/2. And we do not have an x-intercept since the numerator x squared plus 1 has no real zeros. So if we set it equal to 0, we don't get out any real solutions. Next, we're going to determine if our graph intersects our oblique asymptote at y equals x plus 2. We do that by setting our function equal to our asymptote, which is x plus 2. To solve this, I'm going to need to multiply my denominator over, so both sides by x minus 2. On the left, they cancel out. On the right, I'm going to FOIL. My x squareds cancel out, and I get a false statement, which means no, my graph does not intersect the oblique asymptote. Now I've gone ahead and graphed what I know. I know I have a vertical asymptote at x equals 2, an oblique asymptote at y equals x plus 2. I graphed that one by starting at 2 on the y-axis and then doing my slope up 1 over 1 until I got my line. And then I also have a y-intercept at, I believe it was at negative 1/2. Yep, negative 1/2. So since I have that point down here, I know that since I don't cross any of my asymptotes, I can just draw this part of the graph, just like that. Now I need to look at the left side of x equals 2 and see what's going on. I'm going to test the number 4 since it's to the right of 2. When I plug that in, I get out 8.5. Now I know that's going to be above my oblique asymptote, so my graph is going to look like this. So here's what our graph looks like.